Hi there, this is Soman and you're watching the Genesis YouTube channel. Today we will discuss a very simple but slightly tricky problem involving two blocks and three springs which are connected to each other as shown in the figure. The question goes like this. Two identical small blocks A and B, each with mass m, are connected via a light horizontal spring having a force constant K. So this one has a force constant K, the middle one. And the whole system is kept on a horizontal surface. Two additional horizontal springs identical to the first, these two connect the blocks to the fixed rigid walls as shown. The carts are free to oscillate under the effects of spring in one-dimensional motion. Under suitable initial conditions, the two carts will oscillate in phase according to a relation like this, whereas XA and XB, both as functions of time, are given by the same quantity A1 sine omega 1t. Here XA and XB are positions of cart A and B relative to their respective equilibrium positions. Under another set of suitable initial conditions, the two carts will oscillate exactly out of phase according to the relation XA is equal to minus XB is equal to A2 sine omega 2t. A1, A2 are the amplitudes, omega 1, omega 2 are the angular frequencies in these two modes of oscillation. Neglect friction at all contacts. Find omega 1 by omega 2. I suggest you pause the video, read through the question again, and try to do it on your own. If you were unable to solve it, I'll give you a simple hint that in the first mode, only the middle spring is relaxed at all instants, and in the second mode, each block experiences a spring force due to two springs. So we now go ahead with the solution. In the first case, both XA and XB are equal and they're in phase. So they are equal not only in magnitudes but also in directions. So both of them are moving in the same direction by the same amount. This immediately means that the middle spring is not going to be deformed. That means the system is oscillating as if A is a separate oscillator and B is a separate oscillator. They're not interacting with each other. And therefore, here we can straight away say that omega 1 square will be equal to K by M. That is your standard one block oscillation. What about the second case? In the second case, there are two things you have to take care of. First thing, if the magnitudes of the displacements are X, then these two are out of phase. This means if I number the springs 1, 2 and 3, spring 1 is compressed, spring 3 is compressed, whereas spring 2 is extended. And what are the magnitudes of these deformations? First spring is deformed by X, compressed by X. Third also compressed by X, but the middle one extended by 2X because both ends are moving by X. Draw the FBD of any one of the blocks, say of block A, then due to spring 1, there is a force Kx like this, and due to spring 2, it is going to pull it like this with a force K into 2X. So the net force acting on it is 3Kx, and MA will be equal to minus 3Kx in this case. Therefore, A is equal to minus 3K by M times X. So this quantity is your omega 2 square. So omega 2 square is 3K by M. So omega 1 by omega 2 will become 1 upon root 3. That is your answer. I hope you like this question. Keep watching for more such questions which will be useful for you in the upcoming JEE Mains and the JEE Advanced. Till the next time, stay healthy and stay safe you all.